Good evening, chemistry corpuscles. Here we are with what is, bar none, hardest stuff for the year. And we're going to be doing this in two segments. We're going to be predicting products for types of reactions, and in this video we're going to do synthesis and decomposition. I'll post another video later for single displacement, double displacement, and combustion. So let's roll. Because this is the hardest thing of the year, I'm going to be doing it in excruciating detail, showing every little thought that goes through my mind when I do one of these problems. If it's a little much for you, then, sorry, you're going to have to sit through it or skip ahead. But I don't want to lose anybody on this. So you're going to break these problems down, most of them, into 3 steps. Checking your reactants so you know what type of reaction it is. Predicting your products, and that almost always includes charge balancing, and then balancing the reaction that you made. So the first step is to check your reactants, because unlike what we did before, you're going to have to figure out the type of reaction when you're only seeing the reactants. So you don't get to see the right side, the products. You only get to see the left side, the reactants. If I'm going to ask you to predict the products for a synthesis reaction, it's going to be set up to where both the reactants are single elements. One of them is going to be a metal, one of them will be sulfur, oxygen, or a halogen, so fluorine, chlorine, bromine, iodine. Is this all the synthesis reactions that there are? No, but this is going to be the setup for any synthesis reaction that I would ask you to predict products for. When you come down to predicting products, once you've identified it, there is going to be one product, and depending on whether you started with sulfur, oxygen, or halogen, you're going to have a metal sulfide, metal oxide, or metal halide. And you're going to need to charge balance the charge of your metal and your sulfur, oxygen, or halogen so that you get the correct formula for it. And then you're going to balance the reaction. It'll be really important on all of these problems to kind of consider these two things separately in your mind. A lot of students run into problems because they're thinking ahead and they're wanting to make the reaction balance, so they try and accomplish that when they're predicting the products. Can't do that. You have to make sure that you're just letting the charge be your guide when you find the formula for your products. And then once that's set, we'll take care of any uneven number of atoms when we balance the reaction. So let's do an example. Okay, so the problem would look like this. The first thought in my mind is I've got 2 single elements, Cs and S. One's a metal, one is sulfur, so that confirms for me that it's synthesis. I'm going to be making one product, metal sulfide. I have to consult the periodic table to get that cesium, is a +1 as an ion, and sulfur is -2. So my least common multiple is 2. I need 2 of the +1s and 1 of the -2s to make a neutral product. So this is my product. Now don't let it bother you that this is going to put 2 cesiums on there and it's not going to be balanced, because we're going to take care of that right here. So I write out my unbalanced. I stick whatever I found my product to be on the right side. Now I can add coefficients. At this point, these subscripts are stuck, so you can't try and balance the reaction by changing them, because that would undo whatever work you did here. So the only thing that you can do is add in coefficients. Since you have 2 cesiums here, you need to put a coefficient of 2 so that you have 2 cesiums there. My sulfur, 1 sulfur, 1 sulfur, so it's balanced. Okay, here's another one. Again, I'm checking my reactants. 2 single elements. One's a metal, one's an oxygen, so that fits the criteria of synthesis. I'm going to be making barium oxide. I check the periodic table to see that barium is 2+, oxygen is 2-. These have equal charges, so my least common multiple is 2, and it takes 1, 2 to get to 2, and 1, 2 to get to 2, so my formula is this. Again, you have to separate this step from trying to make there be equal numbers of oxygens, you might already be thinking ahead, I've got 2 oxygens, I've got 2 oxygens. That's okay. We'll fix it here. If we have 2 oxygens on the left side of the reaction, we need to make 2 oxygens on the right side, so I put a coefficient of 2 there. That gives me 2 oxygens, but it also gives me 2 bariums. So I need to put a 2 there as well. Beryllium chloride, covering all the bases. I've done a sulfide, I've done an oxide, now let's do a halide. So 2 single elements, 1 metal, 1 halogen gas, must be synthesis. I'm making beryllium chloride. So checking the periodic table, B is +2, Cl is -1, least common multiple is 2, 2 2's to get to 2, 2 1's to get to 2. My formula is beryllium chloride. Put that into my unbalanced, and lo and behold, 2 chlorines, 1 beryllium, it's balanced. Leave it alone. So here's some examples for you guys to try. I'd like you guys to pause the video, write them down, give them a whirl, and check back in a second for the answer key. So give it a shot. So here are the answers for these. I hope you got them right. I'm not going to take the time to rehash all of these, otherwise this video will be like 2 hours long. I'm going to go on to decomposition. So decomposition, these stink pretty bad because everything decomposes in its own sort of way. What I'm going to give to you to have decompose are either metal carbonates, metal hydroxides, or metal chlorates. And they all sort of decompose in their own way. The carbonates, you'll have to remember, make a metal oxide and carbon dioxide gas. A hydroxide makes a metal oxide plus H2O, and a chlorate makes metal chloride plus oxygen. And then, of course, balance the reaction. So you won't have to charge balance any of these, but you will have to charge balance your metal oxide and your metal chloride. So this one, I know it's decomposition because I only have one reactant, and it's a carbonate, which is one of the things that I said I would give to you. I want to decompose my carbonate into a metal oxide plus CO2. So my metal is manganese. Now, if you find manganese on the periodic table, you know that we've got a problem because it's D block. So I can't get started making the formula of manganese oxide until I know what the charge on my manganese is. So I have to do that little bit of homework. You'll remember this from our previous unit. So this is the same formula that we use to find the charge to put in Roman numerals for D block and other metals. So I'm going to be doing the same thing here with this. I have 2 carbonates, and a carbonate is -2. So that's 2 times the -2, so that's 4, divided by 1 manganese. So that means manganese is +4. Now that I know that, I can go ahead and work out the formula for manganese oxide. So I have +2, +4, and -2. So my least common multiple is 4. 1 4 to get to 4, 2 2's to get to 4. So MnO2. So my products are going to be MnO2 plus CO2. So this is the first one that we looked at now that we'll have 2 products. The one that you have to charge balance, your metal oxide plus CO2. And you don't do anything, you just put CO2 on there. Now we do have to take care of balancing. This makes me have 2 C's, so I need to put 2 C's. This also makes me have 6 O's, but that's okay because I have 2 O's here and I have 4 O's here for a total of 6. So that balances it. Different decomposition. I know it's decomposition because I only have one reactant, and it's a metal hydroxide. So what my notes just told me, metal hydroxides make metal oxides plus H2O. Once again, I've been mean and nasty and given a D block here. So I'm going to have to work out, before I can find the formula of chromium oxide, I'm going to have to figure out the charge of chromium using the same formula. So I'm taking number of anions, I have 5 hydroxides, times their charge, divided by number of chromiums, 1. So chromium is positive 5. Now I can go about finding the formula of chromium oxide. Chromium's 5, oxygen is negative 2, my least common multiple is 10, so my formula is Cr2O5. Put that in along with water. For my products in my unbalanced reaction, look at what isn't balanced. I have 2 chromiums, so I need to put a 2 here. That gives me 2 times 5 times 1 oxygen, which is 10. So I need to make 10 total oxygens. I have 5 there, so I need to make an additional 5. That also gives me 10 hydrogens, but that's okay. 2 times 5 times 1, 10 hydrogens. So everything is now balanced. One more example here, again, so I'm covering all my bases, just like in synthesis. We're going to decompose a metal chlorate. So the metal chlorate decomposes into a metal chloride plus O2. Thankfully, strontium is on the periodic table in the S block, so I know it's a plus 2 and I don't have to do any of that homework. I'm ready to go ahead and figure out what the formula of strontium chloride is. Plus 2 and minus 1 for my chloride. Least common multiple is 2, so 2 2's to get to 2. 1 2 to get to 2, 2 1's to get to 2, so SrCl2. Put that in with the other product, which is O2, unbalanced reaction. The only thing that I see right now that is unbalanced, I have 1 strontium, 2 chlorines, 2 chlorines, but I have 6 oxygens, so I need to put a 3 there, and that's going to be 6 oxygens. Alright, same deal, some examples for you guys, so pause the video, write these down. I'm not going to play Jeopardy on my little boy's piano. Just pause the video, and on the next slide I'm going to have the answers put up, so get to it. Okay, here's your answers, and this does it for this video on synthesis and decomposition predicting products. So look for the next one to come up, which will be predicting products for single displacement, double displacement, and combustion. Hope this helps. Talk to you guys later.